Hey everybody, welcome back to the channel. My name is Joe and I appreciate you guys tuning in once again. Today we're going to be continuing digging into this little pony motor that I got behind me. Last time we tore apart the engine, we pulled out these broken pistons and disassembled everything else. Today I want to go over some of the measurements that I took on the connecting rods. Also, I wanted to go through the measurements on the camshaft. And then we're gonna reassemble everything. First thing I want to talk about is the camshaft. When I pulled this thing out, I was pretty worried because it looked like the heights of this lobe and this lobe were quite different from this lobe, and you can see that there's a little bit of wear on this. And so I was really worried that this camshaft had been worn and some of these lobes were wiped. Actually, since then, I've looked at some pictures of used camshafts on eBay and stuff, and this camshaft actually looks like it's in really good shape. And more so, when I took the measurements right here, let me look at this. Don't roll away. So when I took these measurements of these lobes, I got 862 thousandths for the first two. Then the next four were all 823 thousandths, or 824 thousandths about. And then the last two were back up at 863. So pretty much the same as what these first two were. So I did believe that maybe the height of the exhaust lobes were different than the intake lobes, and I confirmed that by, you guys might already know this, but I didn't. Looking here at the intake manifold, right here, these two right here, these are water passages. This is your intake, so it comes from your carburetor right here, straight down and branches into this intake. These two ports right here and here, these are your exhaust ports, and you can see the amount of carbon that's built up in both of those. And right here matches up with the head. So here's your intake port that goes in, branches off, and it feeds both of these intake valves. You can also look and see the size of these two valves is quite a bit bigger than your exhaust valves. So that helped me confirm that sure enough, you got two exhaust valves. Your outermost lobes here and back here are both exhaust, and your four lobes right here in the middle of your camshaft are your intake lobes. And the heights of these two exhaust valves and these two exhaust valves are right in line with each other, off by maybe actually 5-10 thousandths. So as near as makes no difference, these two lobes are the same height as these two valves. Same thing with these four valves in the middle. So I was really happy to see that, and that helped confirm that actually this camshaft is in pretty good shape, and if I needed to use it, I wouldn't have any worry about using this. Now, moving from the camshaft measurements, going over to the crankshaft measurements. I reached inside here. Let me show you. So there we are. We're looking up inside the engine, and you can see the crankshaft. There's your two journals where the rods ride. And you can see now that my drawing isn't so bad. Anyway, I am not taking the crankshaft out. If I was planning on rebuilding this engine, I would have taken the crankshaft out, and I would have checked the bearings, the main bearings, and you can see that there's a little very light scoring on both of those journals, and I would have done a polish on those journals. But since I'm not doing a rebuild right now of the engine, I did want to check for wear, and so I measured the diameter of those two journals, and so that's what I've done here. And I'm happy to say that both measurements of both journals came out the same. So I took two measurements, like this direction and that direction on both journals, and both measurements on both journals came out the same as 1.060 inches. So
really no wear on on the crankshaft. I looked online. I couldn't find any specs for what the diameter of these journals should be, but since they're both the same, and since the connecting rods are just made of aluminum, we are good. Moving on to the connecting rods. This is where I'm amazed. So if you recall, when I was taking apart this engine, I kept on saying, "Oh wow, there's no bearing material there left here on the connecting rod." Or when I was taking apart when I took the oil pan or cover off the bottom, I was like, "Oh, here's a bunch of pieces of connecting or of bearing material." We've got chunks of bearing. There's some more bearing. There's some more bearing. That's wrong. There's actually no bearing material on these, as I've come to find out. I went and I did some research online, and yeah, sure enough, these little connecting rods are made of aluminum, and there's no bearings in them. They are just plain aluminum. That's what is your wear surface right there. And so it's kind of not a surprise that these pony motors didn't last. And it just goes to show that these weren't really made to run for long periods of time. It's made to basically start your big engine, and so John Deere didn't need to make them heavy duty. And so if you can look here, I don't know if you can tell how oblong that hole is, but if you can't tell visually, here's my measurements. Where's my measurements? Here they are. So for the two connecting rods that weren't broken, I took two measurements, as you can see here, one up and down along the length of the, in line with the connecting rod, and then the other across the connecting rod. For the first one, my number one measurement here was 1.121 or 122 more or less inches. My second measurement was 1.067. So you can just see how far off these two, how out of round, I guess, that hole is. For the connecting rod number 3, look at this. I've got, for the number one measurement right here, I've got 1.173 more or less inches. And then number 2 measurement is 1.082. Now, that just goes to show how out of round those are. But when you take that into consideration to actually looking at how much clearance you have, I've drawn a picture here where this circle is the journal on the crankshaft, and this egg shape is me trying to just kind of show the oblong shape of the connecting rod. For my number one connecting rod, the gap that I had in the two directions, 62 thousandths and then 17 thousandths. So that's nearly a 16th of an inch of free play. I mean, you compare that to normal connecting rod clearances where you want like 3 to 5 thousandths of an inch. Here we are, we're 12 times that. And then you look down here, this should say number 3, at the number 3 connecting rod, 113 thousandths of an inch. That's nearly an eighth of an inch gap of free play between the connecting rod and the journal of the crankshaft. And that's ridiculous. That's so much free play. I tried to show you that free play on the last video. Well, that piston, that's all just slop on the connecting rod where it connects to the crankshaft. Well, here it is in measurement form. So, needless to say, these connecting rods are junk. The two that are still, the two that survived, obviously this one is junk, as is this one. So, at a minimum, if we were to just put this engine back together, we need to get new connecting rods, pistons. I would probably reuse this piston. This piston I can't reuse because just the skirt is so chewed up. Same with this piston, and you can see the marking on the top where this is the one that hit all the valves. When this one broke, it hit the valves on the top of the engine. And that's probably why that one connecting rod is broken. this connecting rod, because this valve, or excuse me, this piston hit that valve. And then this piston, I could probably reuse this piston because it's in pretty good shape. But these connecting rods, like I say, I got to get 4 new connecting rods. And the more I was thinking about it, I probably would be willing to try to use, you can see there's that one liner back there that's chipped and broken a little bit. That one liner is bad, but actually looking at the walls of the liner, let me show you. They're actually not too bad. There's not a lot of scoring. I would probably just hone that out, and as long as that chip down at the bottom that you can see right down there, as long as that chip didn't interfere with the rings or anything, I would probably be willing to risk using that liner. The other 3 are actually in pretty good shape. With a good hone, there's no lip on that. With a good hone, I think those would clean up pretty good. So I think that's enough chit chat. I'm gonna go ahead and I'm gonna set up the camera and let's just start getting this thing put back together. So I've got the oil pump installed, the oil pressure regulator, the crankshaft gear, and then down here, before I put the camshaft in, I want you to see if you can see the bearings for the camshaft. There's a little bit of scoring, but honestly, you know what, it's not too bad. There doesn't seem to be a lot of free play with the camshaft inside of there, so I'm just going to go ahead and I'm going to put some oil on the camshaft and I'm going to stick it right into place. Here's the cam gear right here. I've had it in the oven for about the last hour. Now I'm going to hopefully slide it right onto the end of the camshaft right here, and since this is nice and hot, it should go on hopefully pretty easy. Come on, go on. It is hot. There we go. Look at that. Uh-oh, but it's not timed. Come back off. Well, that cam gear went on nice and easily. However, I wasn't paying attention, and you can see the timing mark right there on the cam gear does not line up with the timing mark on the crankshaft. And by the time I went to pull this cam gear off, it's still very hot. It had actually heated up the camshaft right here, so now everything's hot, and so now this, I can't get that cam gear back off without using the flywheel puller. So what I'm going to do is I'm just going to take off the C-clip here, as annoying as that is, and then I'm just going to rotate that crankshaft gear over a couple of teeth, so at least they're in line. Okay, I got that put back in place. Now you can see right there the 2 timing marks line up. You'll also notice that I flipped around my oil pump gear. I had that on backwards, and so it wasn't really engaging very well with the crankshaft. So now I think that's in place. We've now got to put together the governor. So the governor goes in place here on the camshaft. That slides in place first. And then I've got to put this clip on there. So let me explain how the governor works, or at least how I understand the governor working. So right here you have these pockets in this little ring, and these steel balls sit inside of there. And when the engine's running, due to centrifugal force, these steel balls want to, roll outward like that. However, you have this kind of dish-shaped cup that prevents them from rolling all the way out. And so the balls, as they roll out, they'll ride up on this lip right here. And when they ride on that lip, they'll push this cup that sits inside of there, they'll push this cup in and out like that. And as that cup pushes in and out, that button right there on the end of the cup pushes in and out on this tab. And this tab on that cover is connected to the end of this rod, and the end of this rod is connected to the carburetor. So this is something that I think is pretty interesting and is kind of noteworthy of pointing out while we've got this thing disassembled. This case right here is your front timing cover. You can see here's your front oil seal. And if we look on the inside of this, you can see where the dipstick goes down inside, and you can see your oil level for your engine is going to be right about there. So you're always going to have oil in this cavity, and this cavity is actually connected to this cavity, because if you look right here on the actual engine, this cavity goes inside the crankcase, and there's actually another connection out here. So even though you can't really tell from just looking at this timing gear cover, this cavity is connected to this cavity. Now, so this bolt is the drain plug for the starting motor, and if you loosen this, what it's going to do is it's going to open up a passage from this cavity down into this little cavity. And this cavity right here is not connected to anything else except for, look here on the bottom, it has a hole right here, and that hole is what drains the motor oil from the pony engine down into the crankcase of the big diesel engine. It's kind of hard to explain on camera, but hopefully you were able to follow that, or hopefully I was able to explain that in a way that made sense, and you could see what I was talking about. So at this point, we're actually back to where we started. I'm going to go ahead and I'm going to start to put the heads on. First thing I'm going to do is put the lifters in place. I've had these soaking in some oil. And now I know that technically you would want the lifters to go back on to the lobe of the camshaft where they were riding before, but I'm missing a lifter. So there's no way that I could even get the lifters to match, even if I wanted to, because I would have to buy a new one, or a new used one. We will have 7 out of 8 lifters in place. I don't know if it matters which head goes on which side, so we'll just start with this one right here. Also, there's no head gasket, but that's fine. We're not going to really torque stuff down that much anyway. Before I put this other head on, let me show you this. So, this little hole right here, and this same one over on this side,
These two holes, when I cleaned these heads off, were completely plugged and full of gunk. And I blew them out, and it's worth noting that those holes are actually down in the bottom corner of the head. And so when the head is installed, that little passageway is where oil flows from here up with the valves. It flows from these valves down and it drains back into the crankcase through that hole and that hole. So with those being plugged, I don't know how oil was getting from the heads back down into the crankcase. Also, I mentioned that we didn't have head gaskets. Well, we do have head gaskets. They're just the used ones, but I'm going to put them back in place. Let's go ahead and stick these push rods down inside the engine. Now remember, this one right here, this valve, does not have a lifter in it, so I'm not going to do anything there. Okay, all those push rods are down in place. Now, let's go ahead and put the valves on. With the valve train installed, we need to retain this shaft that the rocker arms pivot on. If I rotate that shaft, you should be able to see a hole right there. See that? Get that set screw installed right there. I just finished gapping all of the valves and the rocker arms. The way that the manual says to do that is when you have, for example, right here, so I'm turning the flywheel. When this valve is in its fully open position, so this is the exhaust valve, when that valve's in its fully open position right there, then you're supposed to adjust the intake valve or the opposite valve for that cylinder, and you should have about 0.08 of an inch. So I'm going to pop this cover off, and I want to see if there is a thermostat under this cover, because, oh, that's tight. Oh boy. Because from what I read online, they had an early style and a later style pony motor. The early style did not have thermostats. It was the later style that had thermostats, and they also had a serial number down here on the engine block. This does not have a serial number, and it's from a 720. I don't know which year the 720 was, if it was one of the earlier green dash style 720s, or if it was the later black dash style 720. But since there appears to be a thermostat on this intake manifold, I'm kind of wondering if this was kind of at the cusp when they were switching over from the old style pony motors to the new style. And so this one, maybe it got a new style intake manifold, but the engine block was the older style. Let's see what is inside of this. Let me grab my mallet. Okay. That looks like a thermostat to me. I don't really want to damage it, but I do want to see how it works. Oh, there it goes. Yeah, so it pivots right here. So it moves. Don't know if it still works, but there is a thermostat in there. This was this L bracket that I didn't really know what it was to begin with. And one viewer told me that it's a bracket that goes up by the carburetor. And I'm assuming it goes right here on these two bosses. And I think they said that it holds the spring right here. So probably this spring. Fortunately for me, I do have the carburetor for this engine. It's not perfect. That bolt hole and this bolt hole right here, those are both stripped, but for parts it should work pretty good. And if I needed to, I could repair those bolt holes. But let's throw this on, because I want to see if this lever right here fits right there. Now you can see how the governor works. So as this shaft coming out of the governor moves in and out, it regulates the throttle. This is the choke. The last thing that I'm going to do before I call this project quits is I want to install the clutch. And I believe that these springs go on here and hold the pressure plate out and away. And then this housing fits over it like so. There we go. Okay, now these bolts right here, I'm going to lock into the flywheel. So I'm looking down inside the clutch right now, and you may think that I need to center this disc while I tighten these bolts down, but actually I don't think I need to, because unlike a car, this clutch disc is free and not pressed against the flywheel with the pressure plate until I press in on these tabs with the transmission to start turning the big diesel engine over. And so I just need to kind of make sure that it's free inside of there. Tighten up all these bolts. And then just when I'm connecting the engine to the transmission, it'll be kind of a pain, but it's not like a car where you have to have an alignment tool in there. Well guys, I think that's going to do it. We got the engine put back together. It's all in one piece. We have really pretty much most of the parts we have, which I'm pretty happy about, because it had sat disassembled, mostly disassembled, for so long in the back of a storage unit. So to be able to get it put back together like this, I think is a success. To get it going, we would still need to get a few more parts. We need a new set of rods and a couple of new pistons and an ignition system and a starter. So still a little bit of an investment to get it going, but
for the most part, I'm just happy to see it all back in one piece. And I appreciate you guys sticking with me through the series. And if you have any comments or questions, or know where I could maybe get a couple of used parts pretty cheaply, I don't really, it would be fun to get this going, but I honestly, I don't want to dump a bunch of money into it to get it going. So if you do know where somebody would have a couple of extra parts laying around that they would sell for cheap, you know, let me know, because I think it would be worth it to spend a little bit of money on this thing to get it going. One thing, it's kind of interesting. So here's one of the pistons and rods from this pony motor, and just how small they are when you compare it to a normal piston and rod out of a John Deere 2-cylinder. So this is out of my 1948 John Deere A, and you just see how large the whole system is compared to what's inside this pony motor. So just to put things into perspective.